Dilations, it is the very last transformation type that we're looking at. The size of an object can either get bigger or smaller, and it depends on the scale factor, and they have to tell you the scale factor. If your scale factor is bigger than 1, it's going to make your shape bigger. So this triangle ABC is going to get bigger. Guess what? Since it's a scale factor of 2, this sucker is going to get twice as big. If my scale factor was less than 1 and we had like a fraction, like, I don't know, 1/2, then this triangle would shrink and it would be about half the size. Actually, it would be exactly half the size that it was previously. So that scale factor gives us a lot of information. What we need to do to be able to work out this problem, though, is we need to get the ordered pairs for the corners of whatever shape that we're dilating. Okay, so let's look at A. Your goal is to get an X number and a Y number for this dot. If you can say your ABCs, then you should know that X comes before Y. So we have to get our X number first every single time. Now I've got a space down here for A, so that way you can write your ordered pair right here. Take a look at point A and go straight down to the X axis. You can see that it lands on -2, so our X value for A is -2. Yes, we do put parentheses around our ordered pairs, so put a parentheses there and then -2 and then a comma. Now, we have to go back to point A and we have to find out where's it at on the Y axis. Hopefully you can see that it's hitting at +2 on the Y axis, so our Y value is +2. So without me doing a lot of talking, let's just go get the coordinates for B and C. And okay, I see what my mistake. I've been getting point C and I've been writing them here at B, so we're just going to slide this down to C. And now we can go get the coordinates for point B. Please be very careful that you're actually finding the X coordinate first. That is about the hardest part of dilations, is making sure that you get the correct ordered pairs, the coordinates for each point that you need. And now let me show you the easy part of how we finish this up. You take the scale factor, in this case 2, and you're going to multiply the X number and the Y number of each coordinate pair, right, of each point that we got. So 2 times -2 is -4, and that's going to be our new X value for A prime. So we're going to write -4 right here. And then we take the scale factor again, and this time instead of multiplying the X value, we're going to multiply the Y value, the second number. So 2 times 2 is 4. And then we just come back and we do the same thing again. 2 times 3 is 6. 2 times 3 is also 6. And then finish it up with C down here to find the coordinates of C prime. 2 times 3 is 6. And then 2 times -3 is -6. So now if we can just go and plot the points for A prime, B prime, C prime, we'll be all set. Let's go look at A prime. It's -4 on your x-axis, so -4 is right here, and it's at 4 on the y-axis. So it kind of looks like this. This is -4 on your x-axis, and then it's +4 on your y-axis. And you would see where the two cross, and you could see they would be hitting right here at -4 on the x-axis and +4 on the y-axis. A prime's good. Let's go do B prime. It's at 6 and 6. 6 on the x, 6 on the y. And then C prime would be +6 on the x-axis, -6 on the y-axis. Connect the dots and we're finished with this one. One final thing I'd like to mention, we have already, but how much bigger is the red triangle than the original? Well, that prime triangle is twice as big because my scale factor is 2. I'll do a separate video for number 16 right here where we see a scale factor is less than 1 and this triangle will shrink down lower. So just look for that one. It should be posted right below this one.